In this video, we're going to be looking at transformations and specifically looking at some cubic graphs, how dilations, reflections affect them, and also finding out how we can have an equation such as y equals 2x plus 3 squared or cubed, and looking at how we can find out what dilations and reflections can go from y equals x cubed to get to that equation, rather than previously where we said that this dilation, this reflection happens, and therefore we've changed it from this graph and we've gone to here. Rather, we're going to get this graph and we're going to have to find out which dilations and transformations have occurred. So it's like the opposite direction, the opposite way. So to begin with dilations, so if we have a sort of power basic form of the quadratic graph, we have y equals x cubed. Then this is a green line. Then we can dilate it from the x-axis and then by a factor of a. So if we're going from the x-axis or parallel to the y, then we can get the blue line and the orange line. Now, if we're dilating by a factor of a, and we'll say that this line here is y equals ax cubed. And then this basic one is when a is equal to 1. So orange is when a is less than 1. So let's say a is a half. And the blue is when a is equal to 2. So example, this would be y equals 2x cubed. And then the orange one may be y equals a half x cubed. And you can see the effect on the graphs. Now, what about if it's reflected? So if it's reflected in the x-axis. So if it's reflected in the x-axis, then we have to replace x with negative x. So we'll do that. So y is equal to negative x cubed. Now negative x cubed is just equal to negative x cubed. So that means y is equal to negative x cubed. And then if we graph that, we're reflecting in the y-axis, we'll get a graph that looks like that. But what happens if we reflect it in the x-axis? So reflect in x. Then that means we replace y with negative y. So now we're replacing y with negative y. We have negative y equals x cubed. Take it to the other side, so y is equal to negative x cubed. And we actually have the exact same equation. And you can see that if you replace reflecting the y, then we get that one. If we reflect in the x, then we're going to get the exact same equation. And you can see why that's the case. Because, well, through mathematically, how it gives the same result, as well as if you look at y and then you look at x, you'll see that they both reflect and give the same equation. Now, an interesting example for this one in which you have this sort of like negative x and then cubed or squared or to the power of something is when you have the quadratic. So just instead of a cubic, we now have a quadratic. So let's say we have y is equal to x squared. So if we have this graph here, what happens when we reflect it in the y-axis? Well, it's not going to change. It's going to be the exact same graph. So therefore, the equation should be the same. So let's see if that holds true. We're reflecting in the y, so replace x with negative x. So y is equal to negative x squared. But negative x squared is just equal to x squared. So therefore, y is equal to x squared. And we see that when it reflects in the y-axis, it doesn't actually affect the graph at all. If it reflected in the x-axis, then it would, and it would go down like that, and that's because you're replacing y with negative y, which would give you y is equal to negative x squared. So what happens if the graph is translated? So translated 3 units in the negative y direction. If it's negative y direction, that means we have to replace y with y plus 3. Then that means we get y is equal to x plus 3 cubed. That means x equals negative 3 is the x-intercept. So here is negative 3, 0. And we get the exact same graph. And you can see that there. To also test that, we can find the y-intercept. And if you were to graph this, you would have to do that. So we'll let x equal 0. Therefore, we find that y is equal to 3 cubed, which is equal to 27. So this is inaccurate. It should be a lot higher, as it becomes a lot steeper. However, we can just draw that in and say that's 0, 27. And then we've got the new equation, so that is y is equal to x plus 3 cubed. So now here's a question about what I mentioned before, about if you have an equation and then identifying what transformations have occurred. So state the changes, so the transformations, to transform the graph y equals x cubed, so the basic form, into the graph of y equals 2x plus 3 cubed minus 4. So the way I'd approach this question is I'd say 2x plus 1 cubed plus minus 4. Then I'd plus 4 the other side. So I'd get y plus 4, which is equal to 2x plus 1 cubed. Now I'd divide both sides by 2, and that means I'd get y plus 4 divided by 2 is equal to x plus 1 cubed. Now I've got it in this form where you can see that y has been replaced by this value here, and x has been replaced by a value x here. However, I've still got the cubed on this side. So to get from here to here, I need to do two replacements. I need to replace y with y plus 4 over 2, and then I need to replace x with x plus 1. So two things that have occurred. So there's been a dilation by a factor of 2, now replacing y, so it has to be dilation by a factor of 2 in the from the x-axis. By a factor of 2 from the x-axis. So that's the first thing. Secondly, there's no reflections, but there are two translations. So there's a translation in the y direction, so -4, so in the negative direction. So translation 4 units in the negative y direction. And then there's also been a translation in the x direction, which is also negative, so -1 in the y direction. So if you're writing this down as an answer, you could then say that the three things that have occurred. So dilation by a factor of 2 from the x-axis, which I've just said down there. And then you say translation 4 units in negative y direction. And then also there's a translation 1 unit in negative x direction. So if you weren't sure how to graph this graph, and then you should be able to work out what the point of inflection is because it's in the point of inflection form, which is -1, -4. If you're not sure what it looks like, then you can, and you know what y equals x cubed looks like, then you can go from this initial equation, apply these transformations, and you'll get this equation here, and therefore this graph here.